Assalamualaikum and hello. Today I want to present about our case study DJM482 Programming Logical Control by class DKM5A by Madam Nurlizawati. I want to introduce to our group member. Firstly, myself, Muhammad HAFIZUDIN bin Muhammad ZAID, 24 DKM22 F1053. Next is Muhammad IFHAM bin TERMIZI, 24 DKM22 F1025. Lastly is Fathor RAHMAN bin FAUZAN, 24 DKM22 F1008. Firstly, for the introduction, ensuring safety and precision in industrial cutting operation is priority for manufacturers. The automatic shearing machine is designed to address these needs by combining automated control with advanced safety features. The system minimizes operator involvement in potential hazardous tasks, thereby reducing the risk of workplace injuries while maintaining productivity. For the problem statement is shearing machine pose significant safety risks, including severe cuts, crush injuries, and amputations due to manual handling. Current safety measure, example, manual emergency stops may not fully mitigate this hazard, especially with human error. Workplace accident can lead to operational downtime, legal issues, and increased insurance costs. There is a need for an automatic shearing cutter that minimizes direct human interaction with cutting mechanism. So the component we use is PLC timer programming. We use relay timer. So PLC timer are internal PLC instruction that can be used to delay input and output signals in the PLC program, so that we can delay the cutting process in the machine.
So next, this is input and output table. So the first row is input, the label is PB1, and the description is push button 1. So the second row is input, the label is B2, the description is push button 2. And the third row is output, label is R1 as a recall, and we have the output as a main output signal. And we have a timer, the label is T020, timer 1 we set as 100 ms unit, set to 10 seconds. And then we have the timer 2, T050, timer 2 we set as 100 ms unit, set to 10 seconds. So this is the numeric table. So for the 000, the instruction is LD, the data is 0001. And then we have 0001, the instruction is N0, the data is 002. And the third one is 0002, the instruction is O, the data is 0003. And then we have 0003, the instruction is output, the data is 0003. And then we have 0004, the instruction is LD, the data is 0003. And then we have 0005, the instruction is team, as a team, the data is 0 to 0, hashtag 100. And then we have 0006, the instruction is LD, the data is 0 to 0. And then we have 0007, the instruction is output, and the data is 10000. And then we have the 0008, the instruction is LD, the data is 10000. And then we have 0009, the instruction is team, the data is 030, hashtag 100. And then we have 0010, the instruction is LD, and the data is 030. And then lastly, we have 0000011, and the instruction is output, and the data is 0002. This is the circuit ladder diagram. In rung 1, we have PB1 and PB2 and not. The bottom of PB1, we have R1 or, and we have the output R1. At the PB2, we have R1, and then we have the timer that set 100 ms as 10 seconds. And the round 3, we have T020, and then we have the output. And the round 4, we have the output. Then we have the timer 050, set 100 ms as 10 seconds. At the last round, we have T050, and then we have the output PB2 as a reset for the circuit. So next, this is the flowchart of our circuit. We have to start the circuit. Does it have a relay? If not, we have to remake or redo the PLC for delay. If yes, we have to the machine will do a cutting process. And then does it automatic off? If no, we have to make a modification on the PLC system or relay. If yes, the circuit will end. So this is our ladder diagram video. So we have first, we have to set the push button 1 on, and then reset the push button 1 off. As you can see, the timer is working properly. The timer will energize the power to output, and then the output will energize the power to the timer, and timer 2, the timer 2 will count until 100 ms or 10 seconds, and then the timer will energize the power supply to the PB2 as a reset for the circuit.
Next, implementation plan. First, assessment and analysis. Conduct a risk assessment. Evaluate current safety risks in the operation of sharing machines, particularly focusing on manual intervention, points and potential operator exposure to moving parts. Second, design and development. PLC integration. Design and program a PLC based control system to manage the automated safety features and machine operation. Third one, testing and validation. PLC simulation. Test the program PLC logic using simulation software to confirm the responsiveness of safety features such as sensor triggered, stops and timer based operation limits. And the last one, training and education. Operator training. Train operators on how to start, stop and reset the machine safely, emphasizing the PLC control safety mechanism and their roles in ensuring operator protection. Discussion. The main parts of presentation on PLC control sharing machine cutters would include safety and timing. PLC controls the cutting process accurately. This concept of safety device such as emergency stops, overloads and sensor that show when operators are present. All of these prevent incident and ensure that safety standards are obeyed too. It has program delayed before starting, allowing time for operators to move clear and check positioning. This delay will eliminate accidental start and reduce injury risk. It improves safety and performance by controlling delays, cycle sequencing and providing real-time feedback. And the last one, conclusion. In all, PLC control sharing machine cutters offer major improvement in safety, precision and efficiency for industrial application, incorporating features such as emergency stops and overload protection along with sensor take care of the full safety of the operator in line with regulatory standards. It provides extra protection through program delay times before machine start, preventing accidental starts, confirming that proper positioning has been performed, together with effective cycle sequencing, programmability and real-time feedback. PLC ensure that these machines are reliable and of high performance. This adds up to make PLC one of the most important elements in optimizing modern manufacturing processes and maintaining a high level of productivity. Thank you. That's all from us about this case study presentation. Thank you.